Hi guys, in the previous session we had learned what exactly was linear search and then what is the logic behind linear search. And in this session we are going to do the same thing with hands-on program. We'll try to write the program, execute it and try to understand, right? So now here is the simple code. I want to start off with reading first the number of elements. Like first thing is we will be reading how many elements you want to work with. Like for example, to say I want to work with 10 elements or 20 elements, you need to request from the user, like what is the size of the list what you want, right? Enter the number of elements, right, or you can say size, and then we will read this, right, and once we read the value of n, which is the number of elements which is required, right, then we need to read the elements, right. So we'll just ask the user to enter the elements, right. Okay. So here I'll just be running a for loop and it starts with index 0 and it goes all the way up to n, right. Here I need to put this into an array. Did I create an array here? No, I have not created an array. Since I have not created an array, I need to create an array. Okay. So I'll be using something called as variable length array, wherein I'm going to create an array of size n, and n is a variable, n is not a literal, it's not a little, right. Now you should be careful that this statement is placed after the scanf and not before the scanf, because only after the scanf you know what is the size of or what is the value of n. Based on that we can create an array of size n. Clear? Right. Now one by one we will be reading the elements of an array. So we do require a address of operator while reading it. Okay. So this reading is done, right. Okay. Now once you have the elements, we need to ask the user for the key element to search. So I'll just ask the user right, and let's declare that particular variable also, right. So we'll try to declare it, right. Now this part has actually completed reading of all the required inputs, the size of the array, the elements of the array, as well as the element whatever you want to search. Now the next thing is for writing the logic for the linear search, which we already done in the board part. So what we used to do is we used to start the index from 0 up to n. I always used to compare every element of an array with the key element, e of I, or you can say ERR of I equal to key, right. Now we had also used Bool data type. Now remember, when you want to use Bool data type in C, we need to include stdbool.h, right, stdbool.h. Clear? Okay. So bool, I'll just write found equal to false, and then I would say found equal to true, right. I would strongly recommend having the flower braces here. So even in fact you have only one statement inside the for, and the other statement is inside the if. Even with this, without this braces it works, but still I would recommend that you place this flower braces, guys, right. Right. Now once you complete this loop, then you can just verify what is the value of the found variable. If found is true, it means that the element was found. Fine, simple, right. Let me quickly run this particular program and try to understand if this program is working fine or not, and then we'll try to add few more statements on that and try to modify that. So first let us say I'd like to work with 5 elements. You can enter this element, you can enter in any order. It's not necessary that it should be arranged, because it's a linear search. There's no compulsion that it should be in sorted order. So you can enter any key element whatever you want to search. Let us say I want to search for 21. 21 is found. The same way you can also check out for the element which is not present, right. It is not present in the list, so okay, it should say not found, it is working fine. Clear? Okay. Now, the next thing is the element can be the first element, the key element can be the first element, or it can be the second element, or it can be the last element, or it cannot be present at all. Now, how many times the loop is repeating, right? This particular loop will repeat n times no matter the key element is found as in the first comparison or the key element is not at all present, right. If you just want to know how many times the loop is repeated, I will just try to write a very simple statement out here, right. So, I will just write I equal to percentage d, right. Through this I can just get to know the number of times the loop is repeated. Okay, that particular message will be printed, right. So, I want to search for 1. Remember, the first element is the key element, but you can just observe that loop repeats 5 times, I 0, 1, 2, 3, 4, 5. Now, the question is, when you already found the element, what is the need for you to proceed further and do remaining comparisons? It is not required. So, if you want to reduce that, okay, what you can do it is, we can just put a break statement, okay, once the element is found. Is this clear? Whenever the element is found, you can stop the comparisons. Now, let me try to run this, and then let us say that I would like to again take up this element. I want to search for 1. First iteration we found the element, the break will terminate the loop, but assume that you want to search for 5 or you want to search for element which is not present, right. In that case, it will go through all the iterations. Clear? Okay, right. Here, fine. 6 is not present, so it will repeat all the 5 times. So, we can say the worst time complexity, in the worst case, if the element is not present, okay, then we require n number of comparisons, wherein if the element is present, it can be less than n, meaning it can be anything from 1 to n. Like if the first element is the key element, then we need to repeat the loop only once. That is considered the best case, right. If the first element is the key element, that is considered the best case, guys. Okay, right. Now, this is just telling you that the element is present or not present. Now, if you want to know where it is present, right, then what you can actually do it is, instead of using this Boolean variable and just trying to have the information like it is found or not found, okay, instead of that I can just try to have an integer variable, right. I will just try to have it as found itself, right. Now, in this I would like to capture the index. And I know that the array index can be anything from 0 to n minus 1. So, initial value of this should be such that it cannot be one of the valid index, right. So, I would like to say that it is minus 1, right, indicating that it is not referring to an array kind of thing, right. So, whenever it is found, what we do it is we place the value of I, we place the value of I, we do not just put true, we place the value of I and then we come out, right. Now, I would say if the value of I, okay, sorry, if the value of found variable, if it is minus 1, the element is not found, but if it is not equal to minus 1, I will say if it is not equal to minus 1, then element found, and whatever is the value present in that particular variable, the found variable, that is the index, element found at index. So, instead of the variable name called as found, you can also use other names, like for example, it is the index, right, you can just use that also. Okay. So, let me just try to run this, let me just say 6 elements. Now, try looking out for the element which is already existing. Earlier it used to only say the element found, but we never used to give the index, but this part you can just see it also gives me, okay, the place the element is present, right. Remember, we had 6 elements, but okay, since this was your 5th element, after the 5 iterations it has stopped, right. Now, if you want, you can again rerun this, and then I want to search for 21, clear, right. So, this is the program, guys, right. Thank you.